All right. Can you all hear me? Yeah? Too loud or better? All right. Peyton Strain, are you here? Peyton? Okay, if you don't want to raise your hand, you're not in trouble. Just got the paperwork here you asked me for, so. Okay. We're going to finish up where we left off on Monday. I see a few people that have skipped today. So fortunately I don't see you actually. I see the lack of people that were here on Monday. We're not going to do a participation activity today, but I would highly encourage you to come next week. Okay? And you'll see how these things look. We're trying to come up with ways to encourage you all to get engaged with the material. Sometimes that's just come into class, go into a review session, go into an SI session. I stayed up really late last night. How do some of you know that? For me, I stayed up really late last night. How do some of you know that? Because some of you got an email from me at like an ungodly hour, a response, because you're struggling with accessing your GRL quiz, right? So yes, some of your colleagues waited to the last minute. How many of you got an email push from me reminding you yesterday evening to take, okay, so it's working. Just trying to make sure you don't miss stuff. Remember, we dropped your lowest 2 quizzes, okay? So there are some freebies. I don't want it to be the first one, all right? You're still having issues. Again, let me reiterate, I am not an IT expert, okay? I don't even know what it stands for. GRL has a web support line. There's a phone number. I imagine that they're backed up because it's the beginning of the semester. So give them a couple of days to respond. But it is kind of squeaky wheel gets the grease. Like you continue to send in a web support day after day or make a phone call every other day, they should get back to you. I do not know what's going on with the bookstore, okay? I'm sorry. I think next semester I will try hard to push a message out saying don't buy it from the bookstore. Like I would just get it through the publisher unless you absolutely want the hard copy. Because if you're buying from the bookstore, you're going to get a hard copy. On the inside cover is going to be the code. If you just buy it from the publisher, you can buy it today online with a credit card. And you have online access to the ebook. So it's kind of up to you. All right? If you've got some other issues that we haven't been emailing about, I mean, literally, I was emailing with like 50 of you last night trying to troubleshoot stuff. So, and again, I'm not complaining. I'm just saying we got to get this stuff sorted out because you have another couple of quizzes due, right? So 126, which is Friday, you have quiz 2 and 3 due. Did you guys see that? I'll send out a reminder. If you have questions about the quiz, I'm going to point you to the TAs. And that could be like, hey, why did I get this question wrong? I don't understand this question. I think I may be eligible for some points. Again, I want you to do it diplomatically, politely. It's fine if you disagree. It's fine to challenge, but you've got to do it in a respectful way, whether that's myself or the TAs or the SIs, okay? Just because you think it's lame question, dumb, okay, don't lead with that. Try some diplomacy, okay? Any other questions, housekeeping questions before we get started? So quiz 2 and 3 are due Friday by 11:59 p.m. Gives us a couple days to sort things out. What do you call an angry carrot? What do you call an angry carrot? A steamed veggie. A steamed veggie. What do you call a well-balanced horse? Stable. Come on now. Okay, and why can't you hear a pterodactyl going to the bathroom? Why? Because the P is silent. Brilliant. You all are brilliant. All right. The jokes don't get any better. You just actually get less sharp and more dull. And I just lure you in and you start laughing. Okay? I realized this entire stage is new. I watched the lectures from last spring, and I'm like, that's why I keep running into stuff, and it's super awkward, is they installed an entire stage. So I'm not super observant, but it is on video. Okay, we left off, and I don't like to rush. I want the lectures to kind of be interesting and storyboarded in a way, right? We're trying to tell a story about the topic. And so the topic on Monday was all about these building blocks of life that make up you and I. You know, we're all really mostly the same on the inside from a matter standpoint, right? And we're not just to each other, but to the environment around us, right? All matter is mostly the same. And stuff is just put together in different organizations and compartments. And today we're going to look a little bit more on some of those compartments. But first we got to finish out the lecture that we were talking about with respect to proteins. So on the right side of the slide here, I'm showing enzyme activity, taking a dimer, sucrose, and breaking it down into its constituent parts. And sucrase, ending in ASE, which is an enzyme, which is a type of protein, most enzymes in the body are proteins. What do we know about these proteins if you subject them to high heat or low pH? Where did my key participant go, that young lady that was here? Where'd you move to? Oh, there you are. Okay. You're my pH gal. What do we remember about proteins if you subject them to high heat? What happens to them? They denature. That's a fancy word. Okay? You guys are paying for this education, so use those words. They break down. Someone else said break down. That's another way of saying it. They unfold from their quaternary or tertiary architecture. If they unfold, they lose their activity. But in the right configuration, this enzyme sucrase nicely cleaves this disaccharide into two monosaccharides. So enzymes are proteins that are going to catalyze reactions. They're going to lower the activation energy. They're going to stimulate what we call an enzymatic pathway to be initiated. They're critically important. And if I back up, we looked at the egg example, which is where we left off on Monday. Okay, so that's why it's important that your enzymes in your body are maintained under a normal homeostatic environment, so they maintain their activity. You're more efficient this way. All right, as we finish it out, that lecture, nucleotides. We have three parts to the nucleotide. We have a nitrogenous base, a phosphate group, and a sugar. The sugar is the ribose. And the triphosphate is the phosphate groups. And the adenine is the nitrogenous base. And so this nucleotide, the most famous nucleotide that we're going to study this semester, is called adenosine triphosphate. Do you remember it? ATP. It's just a building block made up of a sugar, phosphate, and a nitrogenous base. Just some basic chemistry. But it's extremely important, and you and I wouldn't be alive if it wasn't for ATP. A horror slide, right? Some of you are like, oh crap, I thought we were done with that stuff, right? Glycolysis, oxidative phosphorylation. Oh, man. Give me some top-level explanations of what glycolysis is. Okay, so don't stress. Let's just take the stress, throw it away. What is glycolysis? What is its purpose? Glycolysis or oxidative phosphorylation. What's the purpose of these two processes? What do they do for us? It's not a trick question. Has to do with the slide we just got done with. Okay, so they make ATP. They may use things like electron transport chain, Krebs cycle, right? Glycolytic pathway. But in essence, on the exam, what do? They make energy. They make energy in the form of adenosine triphosphate. That's it. 2 different processes to achieve energy. It's like you have a hybrid car. You need energy. You can either use fuel or electricity. Make sense? Glycolysis takes sugar, which we've been studying for about a day and a half now. It takes sugar and it splits it. And it does it really quickly. So it generates energy fast, but it doesn't generate a lot of it. It nets 2 adenosine triphosphates. That's it. A slower, but a more efficient process that yields more energy is like this young lady said. We take an intermediate after sugar or a fat or a protein, we'll show you that in a second, and you run it through what we call the Krebs cycle in the presence of oxygen. Then you take it over into the mitochondria and you subject it to the electron transport chain. You move some electrons around and you actually generate 36 ATP out of oxidative phosphorylation. Why is it called oxidative phosphorylation? Well, because it involves oxygen, which oxidizes things. Okay? We refer to this as aerobic respiration. So 2 different mechanisms. Without oxygen is anaerobic. That's glycolysis. With oxygen is aerobic. Generates more but is slower. You guys with me? Pretty straightforward. That's all I'm really going to test you on. We will get into other things this semester that allow this process to work efficiently or compromise it. But it's important that you understand this. It's also important that you understand there are some other nucleotides, like nucleic acids, RNA and DNA, right? Cyclic AMP, which is a second messenger system. GTP, guanosine triphosphate. So these are kind of filling things out. This picture on the far right is what? What is that picture of? Any ideas? DNA. That's right. DNA is kind of important. Building blocks of life. Right? We'll talk about that here in the next lecture as we finish things out. Questions? Molecules of life. Easy?